Antarctica is the quietest place on Earth, a frozen desert the size of the United States and Mexico combined. No cities, no radio noise, just ice, wind, and silence. But in the data from a balloon drifting nearly 24 miles above that silence, Antarctica did something unexpected. It spoke. And what it said does not fit comfortably inside modern physics. High above the ice, suspended beneath a massive helium balloon, hangs an experiment called ANITA, the Antarctic Impulsive Transient Antenna. The balloon is enormous, roughly the size of a football stadium, and its job is deceptively simple. Listen. ANITA doesn't look for light. It doesn't look for particles directly. It listens for brief radio flashes produced when extreme energy particles interact with Antarctic ice. Specifically, ANITA is designed to catch signals from ultra-high energy neutrinos, particles so elusive they pass through entire planets almost without noticing they were there. Almost. In 2006, ANITA recorded a signal that made scientists pause. In 2014, it recorded another. Both were powerful. Both were clean. And both appeared to be coming from the wrong direction. Not from the sky above Antarctica, but from the Earth below it. According to our current understanding of particle physics, that should not happen. To understand why, we need to talk about neutrinos. Neutrinos are often called ghost particles, and the name is earned. Trillions of them pass through your body every second. They come from the sun, from nuclear reactors, from distant galaxies, and from the Big Bang itself. They barely interact with matter. A typical neutrino could pass through a light year of solid lead without stopping. But that property has limits. As neutrinos reach extremely high energies far beyond anything we can produce on Earth, they become more likely to interact. Physicists describe this using something called the interaction cross-section. In simple terms, the higher the energy, the less ghost-like the neutrino becomes. At the energies ANITA is sensitive to, the Earth stops being transparent. For an ultra-high energy neutrino, thousands of miles of rock and iron are not a clear path. They are an obstacle. Which is why the ANITA signals were so unsettling. ANITA floats about 24 miles above the ice, scanning downward. When a neutrino strikes an atom inside the ice, it can produce a cascade of secondary particles. That cascade emits a brief, sharp pulse of radio energy, a phenomenon known as the Ascarian effect. ANITA sees these pulses all the time. Usually, they come from cosmic rays hitting the atmosphere from above, reflecting off the ice. And we can tell. When a radio signal reflects off the ice, its polarity flips, like a mirror image. But the two anomalous events ANITA recorded showed no such flip. Their polarity indicated they did not reflect. They appeared to emerge from the ice itself, traveling upward into the atmosphere. For that geometry to make sense, a particle would have had to cross thousands of miles of Earth first, at energies where survival is statistically vanishing. Not unlikely, effectively impossible. The technical name for these events is long and unhelpful. Anomalous, upward-going, ultra-high energy cosmic ray-like air showers. The media preferred something simpler, a parallel universe. In 2018, headlines around the world claimed that ANITA had detected evidence of an anti-universe, a mirror cosmos where time runs backward. Those stories traced back to a speculative theoretical paper suggesting that if the particles were a specific type of hypothetical right-handed neutrino, they might hint at a CPT-symmetric universe created alongside our own at the Big Bang. It was a bold idea. It was also highly speculative. The ANITA collaboration itself did not claim this. Most physicists did not accept it, and no independent evidence supported it. So if it isn't a parallel universe, what is it? One possibility is new physics. The standard model is extraordinarily successful, but incomplete. It does not explain dark matter. It does not incorporate gravity. Some theories suggest the ANITA events could be caused by sterile neutrinos, particles that barely interact at all, or by the decay of heavy dark matter particles trapped inside the Earth. These hypothetical particles could traverse the planet and decay near the surface, producing an upward-moving shower. But extraordinary explanations demand extraordinary scrutiny. Before rewriting physics, scientists look for something more ordinary. In Antarctica, that means the ice. The Antarctic ice sheet is not a uniform block. It is layered, fractured, and dynamic. Near the surface is firn, compressed snow that is not fully turned into ice. Deeper down are density gradients, internal boundaries, and even subglacial lakes. Recent studies suggest that under specific conditions, radio signals from ordinary cosmic rays coming from above could reflect internally within these layers. If the geometry is just right, the signal could preserve its polarity. To the detector, it would look like a particle came from below, even though it didn't. In that scenario, the ice itself becomes a distorted radio mirror, a rare one, but not an impossible one. To test whether something truly exotic was happening, scientists turned to IceCube. IceCube is Anita's opposite. Instead of floating above the ice, IceCube is buried inside it, more than a mile deep. It consists of over 5,000 light sensors embedded throughout a cubic kilometer of Antarctic ice. If ultra-high energy particles were regularly crossing the Earth and emerging upward, IceCube should have seen them. So the IceCube team analyzed years of data, searching for events matching Anita's geometry and energy. They found nothing. No excess, no matching signals. This severely weakened the new physics explanation. If Anita detected 2 such events, IceCube should have seen many more. The absence of those signals suggests one of 2 things. Either the Anita events were extraordinarily rare statistical outliers, or they were not neutrinos at all. As of 2026, the mystery remains unresolved. The safest explanation is the ice, that our understanding of radio propagation through Antarctic ice is still incomplete, and that rare internal reflections can mimic impossible geometries. It is not glamorous, but it is how science usually ends. Still, the case is not closed. A next-generation experiment called Pueo, the payload for ultra-high energy observations, is planned to fly with far greater sensitivity than Anita. If Pueo sees the same upward-going signals, and if ice-based explanations fail again, then physics will have a problem, not a small one. Something would be moving through our planet that the standard model cannot describe. Whether it turns out to be dark matter, a sterile neutrino, or something entirely unexpected, those 2 radio pulses over Antarctica serve as a reminder. Science advances not when everything fits, but when something refuses to. Antarctica is still cold. It is still quiet, but it is no longer silent. And whatever passed through it is waiting for us to understand what it really was. If you want to be there when the next impossible signal forces physics to blink, subscribe and stay curious. Veil Origins: Impossible Truths.